Here's a second example. A little bit of a different thing that we're going to calculate in here. We're going to calculate basically the difference between radii of two isotopes. Really would help if you had a quick picture of the diagram of the ion separator region. The radius turns out to be the difference between how far these things move out in a circular path. So what we want to do is we want to find out the radius of each one, then subtract their difference. So we've got carbon 12. Carbon 12, one of the first things we know about carbon 12 is there's 12 total nucleons. So the mass is going to be equal to 12 times 1.67 times 10 to the negative 27 kilograms. Even though we know the mass of a proton and neutron are slightly different, we just assume that the mass of the protons and neutrons are to the 3 sig digs 1.67 times 10 to the negative 27. It's singly charged, so the charge is 1.60 times 10 to the negative 19 coulombs. And we also have carbon 14, and it has a mass of 14 times 1.67 times 10 to the negative 27 kilograms, and it's also singly charged, 1.60 times 10 to the negative 19 coulombs. We have a magnetic field of 4.73 times 10 to the negative 1 Tesla. We have a electric field of 5.87 times 10 to the 4 newtons per coulomb. Well, and then the electric field is turned off. What we want to do is find the difference between the radii of the two isotopes. So the first thing we're going to do again is set up the velocity selector. Undeflected tells us that Fe equals Fm. Again, QE equals QVB. Electric field equals velocity times magnetic field, and velocity equals electric field divided by magnetic field. Been there, done this in the last example. Second formula then has us again looking at the radii of the two paths. So again, it's magnetic force equal to centripetal force, QVB equal to mv squared over r. Simplify this again, so it becomes r equal to mv over qb. This case, we're going to substitute equation 1 into equation 2 again, and then we're going to calculate both radii. So similar to what I did in example 1. Example 1 I was finding mass. This time I'm going to find radius, but it's set up the same way. Substitute 1 into 2. So we get R equals mv, which is electric field over magnetic field, divided by QB. Again, if you want to simplify this again, the final manipulated formula is going to be ME over QB squared. What I'm going to do on the next slide is calculate the radius of each isotope, and then we'll find the difference between those two paths. We have the mass of each. We know the electric field, we know the charge, and we know the magnetic field. So we're just going to do two calculations, then find the path difference. We want the difference between those paths. So R equals ME over QB squared. And then we're going to deal with carbon 12. So R equals 12 times 1.67 times 10 to the negative 27 kilograms times the electric field, 5.87 times 10 to the 4. Newtons per coulomb divided by the charge. These were singly charged. 1.60 times 10 to the negative 19 coulombs. And the magnetic field, 4.73 times 10 to the negative 1. Tesla. We're going to work out R for C12. Then we're going to work out R for C14. First of all, we'll punch this in. 12 times 1.67 to the exponent negative 27 times 5.87 to the exponent 4 divided by bracket 1.6 to the exponent negative 19 times 4.73 to the exponent negative 1, and I forgot to write squared on my slide, but I'll make sure I punch that in correctly. So the radius of this path for C12 is 0.0329 meters. Let's do the radius for carbon 14. It's going to be the same numbers except for the first one. 4 times 1.6 or 14 times 1.67 times 10 to the negative 27 times 5.87 times 10 to the 4 divide by 1.60 times 10 to the negative 19 coulombs times B squared, 4.73 times 10 to the negative 1 Tesla squared. And let's punch this in again. And we get 0.0383 meters. And what we want to find out is the difference in R, which is 0.0383 meters minus 0.0329 meters. Our path difference equals 0.0054 or 0.54 centimeters. Not a big path difference. I probably rounded here. If I would have kept my actual values, I might have got, I think on the sheet it says 0.55. If you did this as one single step and then just took those two values and subtracted their actual answers, you probably would have got 0.55 centimeters. But if you showed your work on here for a written response, I'd give you full credit for 0.54 as well. Key is in this one is we set it up the same way, again using both formulas. It passed undeflected, then through the arc. This time we had to find radius, and we had to find difference in the radius in this question.